Welcome. This is part 7 of analysis of continuous beam. For FEM batch point of view, class number 20. So, those who are general public, for them part 7. See earlier part. And again I told you, these recorded versions are practice questions because everything is so thoroughly told earlier. Start from part 1, study everything. Then, as I told you, you can note the question, directly go to the answer. No hint required, but still brief answer. See, question 7. Notes, I will not talk too much today. Nodes at B, C and D. No node at A. V0, theta is there, theta 0. This all told earlier. Second degree, write the stiffness matrix, find equivalent joint load. Now, when you find equivalent joint load or consider nodal forces for member AB cantilever, see here, when you consider here, 20 down and 8 into 3 down, it will have upward reaction of 20 plus 8 into 3. And it will create anti-clockwise moment about B. So that will give clockwise moment. Because it is clockwise, you got anti-clockwise here. Already explained. There is limit for explaining everything. And for BC span, I will tell you here, just for those who are not understanding. See, BC span, there are 2 point loads are there. Okay, no problem. See, first load is 50, second is 60. Do one thing. 50 is from what distance? 4 from here. If that is 4, this is 6 meter. 60 is 3 from here and 7 here. These are the moments. So, those who want, right here. This moment equal to, see, 50 into 4 into 6 square plus 60 into 7 into 3 square. Then you will get 109.8. Answer is already there. And this FEM is 50 into 6 into 4 square, 60 into 3 into 7 square, both divided by 10 square. Then find the reactions. Oh, that's all. Sufficient as an exercise problem, over sufficient. I need not give further information. Okay, now, equilibrium equation. Only theta B, theta C. Substitute everything. See, not waves. Search for theta B, theta C. Substitute equilibrium equation. Solving unknown. Then, find member forces. Don't consider AB. AB direct answer. I told you later. For AB, see, this moment is directly equal to fixed end moment. That is how much? That is 96 kilonewton meter. Direct answer. And this reaction, this reaction, I'll put it somewhere here. This side reaction will be directly equal to 20 plus 8 into 3, 44. That reaction you have to calculate later. Then you get combined VB. Okay, start. Now, calculation of after getting theta, final moment for BC member, VBMB, VCMC. For CD member, VCMC, VDMD, write stiffness matrix, which are enter the displacement for that member, subtract equivalent joint load. See there, for BC member, see here, I will not write here, you should write. These 4 values, I will not write, I will tell here. Minus 45.36, minus 109.8, minus 64.64, plus 136.2. That member. Minus 60, plus minus 80, minus 60, plus 80. You get the answer. Once you get the answer, prepare the beam with end moment and the result, draw SFD BMD. Okay, now time has come to get the answer. Where is the calculator? I will give the direct answer. Two and 1. This EI is not required. (108.68 kilonewton meter). Never bother what comes. This moment from here I can get that one. .66 kilonewton meter. Okay. Now reactions. This is 44. These reactions I require. This is by equilibrium directly. .65, 68. 54.62. One, that is 54.62. 15 into 8 minus 54.62 is 65.38. This reaction. 65.38. This reaction is 63.27. This one. 63.27. Other one minus 110. 46.73 is this reaction. When you add those two, 46.73 plus 44 will give you 90.73 here, kilonewton. Here, 63.27 plus 65.38 will give you 128.65. See, remember, by chance, if any answer is not coming, maybe some calculation mistake I am doing because I am not solving. I am directly solving the question without writing anything. So, if you let me know, I will check once again. Not a big issue. See how much time it took for me. Little slowly I did. So 1 minute. So I can check again. Okay. Now this 44 I'll write here. This was 44. Okay. Now draw SFD. See SFD. Come down by 20. Again come down by 8 into 3. It will come to 44 here. Go up by 90.73. 46.73. Here, 46.73. No load up to here. Down by 50. It will cross the baseline here. 3.27. Small value. No load up to here. Down by 60. Why calculate? 63. Little more. 63.27. No load. Go up by 128.65. It has to come 65.38. Why should I bother? 65.38. Down by 15 into 8. When you reach here, it will be 54.62 joined by a straight line. Okay. Minus, plus, minus, plus, minus. Bending moment diagram. I told you already. Some importance is there now. I already told you, I will not tell other principle. See, no superimposing here. 96 here. Here, 108.68, little more. 108.68. Here, 65.66. With irrespective of whatever is loading, joined by a straight line. Superimpose bending moment diagram due to simple support beam. 120 here. How 120? Okay. Parabola this way. 120. See, this is 120. How it came? WL square by 8. Now, this span you should be careful. Okay. Last I will tell. See, here 96 here, 0 here, joined by a parabola. That's all. Minus, minus, plus, minus. Now important, how to superimpose here. If central 1 point load is there, WL by 4. If two symmetrical load is there, directly you can get it. The way I am going to tell now. If UDL is there, WL square by 8. But here 2 point loads are there. Therefore, for BMD, for superimposing, make a note. For superimposing purpose, for the span BC, what do you have to do? You consider BC as a simply supported beam, not moments. One load of 60 here, 50 here, 150 here and 160 here. See, this is 4 meter, this is 3 meter. Simply supported beam, no moment, nothing. For this one, draw BMD. How? First find reactions. Simply support beam, if you can't find reaction, I should tell leave the class. That reaction will come 62. This will come 48. Now, 0, 0 here. 62 into 3, sagging, 186 here. Here, 48 into 4, 192. Little more, 192. Plus it is, plus here. Further, because why? This is third semester B level. 192 here, little bigger. 192 here, and if it is wrong, check it once again. 186 there. That is, you have to consider the beam as what? Simply supported beam and prepare the BMD. Okay, now this full is 192, full 186, minus, plus and minus. Hog, sag, and hog. This is the, as usual, shearing force diagram, bending moment diagram. I won't write, every class I am writing, left up, right down, positive for shear force, BMD, sagging positive, kilonewton meter, that all you write. Correctly solve the question. Those who are serious, note the question, directly get the answer. Those who find difficulty in between, check the value. Remember, this is not my usual class. This is only exercise, homework question, but with the limited explanation. It is more sufficient. This is class number 27. Now, tomorrow I will upload 8 and 9. 8 and 9, part 8 and 9. That is the closing part of this continuous beams for analysis for SFD and BMD. I will go for closing part. Okay, thank you.